Hi, everybody. Welcome back to another episode of the Backend Podcast. In this podcast, we discuss everything relating to backend engineering. We share concepts and we break down complex topics so that you can understand the inner workings of a backend engineer. So, in this episode, we have Luciano, who is going to introduce himself, by the way, is a backend engineer with a lot of experiences. And today we are going to be talking about Rust and AWS Lambdas. We are going to understand how they connect together and how you can use AWS functions with Rust. So, Lucian, please introduce yourself.
Yeah, first of all, hello, Solomon. Hello, everyone else listening. Thank you for having me. It's such a pleasure to be here. So, yeah, I've been, I would say, a full stack web developer for most of my career. And in the second part of my career, I've been doing more and more cloud and cloud architecture stuff. So I'm this kind of weird mix between an architect and a full stack developer. And in the last, I would say 4 years, maybe, I developed a passion for Rust as a language that I've been learning on the side. And only recently started to use it in production for some projects. But I think it's a great choice for the cloud in particular, building backend systems, and also for Lambda. There are lots and lots of advantages, but I'm sure we'll get to talk about that as well.
Awesome. So, I actually recently got exposed to Rust and I love it. I've started learning it. In fact, I've kind of created a few books around it and it's awesome. So today we are going to be talking about Rust and AWS Lambdas. Okay, so we are going to merge
Mm-hmm.
these two important technologies together and discuss serverless technologies with Rust. So I have a few questions that I want to go over first before we start the practical part. The first one is I like to know, I like to have a clear introduction to something before I get started with it. So I want to hear from you. What really makes Rust a compelling choice for backend development compared to the fact that we have other backend languages that we can use? What makes Rust a better choice for backend development?
Yeah, there are certainly a few things that are compelling when it comes to Rust. One for sure is the performance because it's a compiled language that is very optimized, that was originally developed to build very low level systems like browsers or even operative systems, like system engineering type of language. Although now has evolved to be more of a general purpose language, it still gives you all the performance guarantees that you will need to have with a low level language. So that's amazing because when you build a backend with this language, then you get something that can be very performant, which means that, for instance, if you're hosting it in the cloud, you can probably get cheaper costs because you don't need to use very big instances. In most cases, of course, there is a big depends on what kind of problem you are trying to solve. But like for general purpose type of web services, probably if you compare it to something like JavaScript, Python, or Java, even the same type of application will be cheaper to host if you write it in Rust in most cases. That's one aspect. Then there are other things. For instance, I really like the type system that the language has. And I think that that particular type system, especially the way that it handles the absence of data by not having null types or the way it handles errors, it kind of forces you, as you're writing your code, to think a lot more about all the different edge cases and make sure you address those edge cases up front. So I think in reality, when you write a piece of code in Rust, as compared to writing it in a more dynamic programming language, in Rust you have a little bit more a peace of mind, so to speak, that the code you are writing is actually not just correct for the main use case, but is also addressing a bunch of potential edge cases that maybe in another language you wouldn't think about them until you have a runtime error. So in Rust, like
Yeah.
if it compiles, you have probably already spent enough time thinking about all these edge cases. Which at the beginning, when you start to learn Rust, especially if you're coming from JavaScript or Python, can be a little bit annoying. Like it's a little bit demanding as a language. But at the same time, when you get used to it, you realize, okay, but now I trust my code a lot more than I was trusting it in Python or JavaScript after the first time I wrote it and compiled it.
Awesome. So yeah, I know about Rust features. For example, one of the features that I love so much is the fact that it gives me a clear definitions of my errors. Like if I have an error that happens in my code, it tells me what happened, how I can fix it, and where I can fix it. So that's one of the features that I really love about Rust. In fact, it seems like it's helping me write my code, something like that. Now, I have other things that I love about Rust, for example, memory safety, concurrency, and all of this. But since you're talking about serverless and Rust, how does these good features of Rust benefit serverless? Okay, so how does it benefit serverless application? For example, memory safety and concurrency.
Yes, to be fair, I don't know if memory safety and concurrency are the main strengths in the context of serverless. I think they are important, but probably not the most important,
Yes.
because often enough, at least in my experience, when you're writing, for instance, a Lambda function, yes, you can do multi-threading, but generally the kind of problems you are solving in a Lambda function are simpler, and most of the time they don't require you to do multi-threading. Maybe you will be spinning up multiple lambdas to handle concurrent stuff. So your code in itself can be a little bit simpler. That's generally, of course, there are some exceptions, but I would say the exceptions are, just exception and probably the minority of the use cases. I think what's really compelling about Rust in the context of serverless is because with serverless you have this, let's say, the way that serverless works in most serverless ecosystem is that you want to scale to zero. So there needs to be some kind of mechanism where you provide your code to the platform that you're running on. I'm talking in abstract sense, but if you are in AWS, that's probably going to be Lambda, but similar systems in other cloud provider will probably work in a similar way. So you're kind of giving a package with all your own code in a way. And then you are telling the cloud provider, okay, I want to listen to a specific event, for instance, an HTTP request or maybe a file being created in the storage system. And then when that event happens, my code needs to be triggered to handle that particular event and do something useful. So the problem that the cloud provider has is that that code that you ship there needs to live in some kind of frozen state, doesn't need to be active all the time. But then when the event happens, that code needs to become active as fast as possible, because of course you don't want to, especially if it's like an HTTP request, the platform should not add a lot of latency. So it needs to figure out a way to spin up the code as fast as possible in some kind of virtual machine, isolated, handle the event, and then after a while, if you're not using that function anymore, clean up everything and put again your code back into this state where the code is available somewhere if needed, but is not in a live instance that is consuming CPU all the time. So all of this just to say that if you're using a language like, I don't know, Python or Java, where there is a virtual machine, the moment when you spin up that infrastructure for the first time, there is an extra cost associated with it because you need to kind of create all of this environment, create the interpreter, interpret the code, and then you can start to run the code. With a language like Rust, and this is not unique to Rust, even if you use C, C++, to some degree, even Go, like all compiled languages probably have the similar characteristic here. Like the code is much faster to just spin up. So the problem that is generally called cold start. So the first time that you spin up this environment, the user might see a little bit more latency, almost becomes irrelevant when you use Rust because you literally have, at least with Lambda, cold starts of like 20 milliseconds, 30 milliseconds, 40 milliseconds, just because the binary that you are running is so much more optimized and small that it can start straight away. So that's to me one of the main advantages when used in the context of serverless. The other thing is that in general with serverless, you are paying by the number of milliseconds that you are running your code. So if you have a very performant language, that most likely means that you can solve the same problem as with other languages, but probably in a faster way, which means that if you compare the two execution, the one that is going to be faster, probably Rust, is going to cost you less because you are running the same, you're solving the same problem in a smaller number of milliseconds, which is your unit of billing for at least for Lambda.
Mm-hmm.
So it's basically these two things. You have better responsiveness of the system because it can come up quickly, and the other one is because generally you can solve problems in a more optimized way and in a faster way. Is going to be cheaper for you to run it in a serverless environment.
Right. So that makes a lot of sense, right? Comparing this to other languages. But I also have one other question, which is more relating to what you're talking about. But what I think I want to know more is in terms of the performance of Rust. Rust is fast, so is other languages, of course. But I want to know, like, in terms of the performance in AWS, what can you say about it when you compare it to other languages? Is Rust more in terms of performance or more faster than other languages when you use it with AWS or not? Okay, so I want to know the performance aspect of Rust with AWS. AWS Lambda, that's what I mean.
Yeah, there is actually a very nice benchmark. I will make sure to share the link so you can add it to the show notes. That is
Okay.
basically running every day because, of course, that whole AWS ecosystem it's a bit complex. It's always evolving, so you
Mhm.
cannot just say at a point in time this is the fastest or the slowest language because the languages change. There are new versions. The runtime change. There are always new
Mm.
versions. AWS can do things internally, different CPUs, different memory configurations. So basically, this benchmark is trying every day to run all these different permutations against the most common languages that are used when building AWS Lambda. That includes Python, .NET, JavaScript, Java. There is Rust, of course, C++, Go as well, and it
Mm.
gives you an idea of a few different dimensions. One is how quickly the environment starts, so the cold start problem.
Yeah,
Then it gives
that's
you an
what.
idea of, yeah, exactly. It gives you an idea of how long does it take for the execution to complete once it started, and how much memory is consuming. I think these are the three dimensions that generally you care about when doing
Yeah.
Lambda functions. And if you look at the different combinations, I think the two main contenders are always C++ and Rust. So they are generally the fastest by far if you compare to the other ones. I think Go is almost always the third one, but then there is a big gap between those three languages and the others. So I think
Mm.
Rust scores pretty well most of the time is the first one, but definitely competing between the first and the second place most of the time.
Yeah.
I hope that
So,
answer your question, but yeah, it's always something that you need to look at the numbers. And also, to be
yeah.
fair, this benchmark can be relatively simple because I think it's almost like an hello world. Then, if you compare more realistic applications, you might have different results. And if you want, I can give you actually a practical example where I worked on a
Mm.
Lambda authorizer function. So it was basically making sure that the token received by the user was valid before making the request proceed. And
Yeah.
I originally wrote this in Python, and then I said, well, this Lambda is going to be called potentially millions of times per day in this specific application. So maybe this is a good case to use Rust to optimize a little bit for cost. So I rewrote that in Rust, and then I did some benchmarks. And surprisingly, the Rust Lambda was only quotes air
Mm.
quotes 3 times faster than the Python one. When I was expecting something like 10 times faster, and then I went to look
Okay.
into the code in Python and I realized that most of the code in the Python library that I was using was actually written in Rust as well. So, so I was only getting the
Oh,
benefits of the runtime itself, but then the problem was already fairly optimized even in Python itself because underneath it was already using Rust. And I didn't realize that because in my view I was just using a library. So before looking into the library, for me that was just Python code. So this is just to say that sometimes you need to look at the specific problems you are trying to solve before just saying
mm.
I'm just going to use Rust because it's going to be so much faster than anything else.
All right, awesome. This basically gives us a very clear explanation when it comes to benchmarking and performance of each programming languages. So I'm definitely going to share the links to the benchmark
Mm-hmm.
on the show notes so that everybody can take a look at it and make their independent choices. Thank you very much for sharing that. And also, I would like to see the projects that you you want to share. But for now, I'm just going to finish up the questions and then we'll move to the practical aspects.
Mm-hmm.
All right. So the next question that I have has to do with some common pitfalls that you might encounter if you're building Rust with serverless applications. Okay, so there are problems or pitfalls that other programmers might encounter if they are using other languages like Python, Node.js with serverless. So since you're talking about Rust, what are the pitfalls for Rust? And
Yeah,
again,
for
yeah, just to add to that, sorry, how can we avoid it? All right, of course,
Mhm.
you share the problems and how we can avoid it.
Yes. So the first one, I don't know how easy it is to avoid. Spoiler is that even though Rust has been in the market, I think for more than 10 years now, so it's not we still call it a new language, but it's not that new anymore. But especially if you put it in the context of serverless, which is also relatively new. I think Lambda just made 10 years a few months ago or last month, I'm not sure, but like this year is 10 years of Lambda. And basically, my point is that, yeah, these are still a combination of the two. Is still something that not many people have done. So
Mhm.
even just finding examples and information might be a little bit challenging, especially if you compare it with Python. I think is the number one language used with Lambda, maybe competing with JavaScript. I'm not sure which one is the first, but the two of them, you will find so many examples. So probably way easier for anyone to get started with those two languages because you can find lots of material. If you have problems, you can probably ask in different forums and you will find people with experience. So I think there is definitely a knowledge gap there that I think eventually is going to be addressed as more people start to explore this field and they create more material. Like the conversation we are having today, like the more people will listen and try it, I think that problem is going to become easier. But right now, it's just something you need to live with and be aware that it's a bit of an experimental field where you might not have the community support that you have with Python or JavaScript, right? So that's
Yeah.
definitely one problem. The other problem is that Rust as a language itself is has this kind of stigma that everyone says it's difficult to learn, which for some cases, like for some parts of the language, is definitely true. There are parts of the language that can be a little bit challenging, like when you get into, I don't know, all the annotations that you need to use to specify the lifetimes. And sometimes you might have, when you start to use generics, you might have lots of like complicated where code where you define all the relationship between the generic types, which is super powerful that you can do that. And sometimes it can be very useful. But that type of code can be very intimidating, and people can just say, I don't understand this. I'm not going to even try to use Rust. I think the reality is that there is a subset of Rust code that is simple enough that people coming from other languages can easily start to write Rust and be productive.
Mm.
So there is another link that I want to share that is called, I think it's called Easy Rust, Rust Easy Mode, sorry, which I often like to reference because I think it's an article, but there is also a talk, and I think that you are linked so people can see also the video if they prefer the presentation style. And the idea is there that when you start to learn Rust, you probably want to start with the easy part of Rust that gives you everything you need to solve most of the problems. And then when you are confident and you feel like, okay, I can write Rust, I'm not scared, then maybe you can start to deep dive into the more complex topics when you need to. I think a lot of people will do the opposite. They just look at everything and maybe they end up looking at all the borrow checker annotations and they get intimidated by that. But if you do the opposite, where you try to ignore all these things as long as possible, then I think you might
Mm.
have a much nicer time and get more familiar with Rust. And then eventually, when you get to these more advanced topics, probably they will make more sense because you have kind of the broader context already. So I think these are the two main pitfalls that I can see that is not necessarily easy to learn Rust if you don't do it in an easy kind of in a structured way where you try to start from the easy parts. And then the
Yeah.
other one is that specifically in the context of Lambda, there aren't a lot of examples or there isn't that like a huge community doing this that can support you. On the other side, I will say that I always been impressed even when I started learning Rust 4 to 5 years ago that there are already lots of libraries and lots of people building like high quality Rust code. So that's definitely not a problem that I would be concerned about. And maybe lots of people might think, oh, but then if I need to do something, maybe I'll need to write all the code myself. There are no libraries, there is no nothing. Actually, I think the library ecosystem is pretty good. So I would say that's at least a great thing that many people might not expect.
Awesome. Yeah, so you've really touched on a lot of problems that I actually see in the community. There are no much communities for us, and that is disturbing because if you have a problem, you are either going to ask yourself or you go out there and search for who to ask, and that's really a problem. And talking about materials, I think when I started, I actually started with the official documentations. So I just follow it chapter to chapter, and when I get to lifetime, it's really difficult. And lifetime is one of the most difficult concepts in Rust, and of course, over time, I get to understand the concept of it. And yeah, so just to add this, my company, Masteringbackend, we are producing a detailed course on Rust. So we are basically following the outline that is specified in roadmap.sh. Yeah. So there's a outline, like the roadmap for Rust, and we are following that, thoroughly to produce a course that goes in depth into what is specified in that outline. So you can check it out. I'll drop the link. But aside from these things that you mentioned, for I don't really have a problem, right? If I have a little communication with somebody that knows this language already and the person points me to a specific direction, right? I think that will do for me because I have experience already, right? And I can just, put one and one together and get to understand the concept. But for beginners, people that may not have any experience in any programming language at all, and they just want to get started with Rust, it's going to be very difficult. It's going to be very difficult for them to get started. And hopefully, in the near future, we'll have a lot of communities just like the way we have with Node.js and other programming languages. Thank you very much for pointing that out.
Can I challenge very quickly your last statement there?
Yeah, go ahead.
And don't really have I don't really have hard data, but I was reading a conversation some time ago where I don't remember exactly who, but they were talking exactly about this thing where, oh, but if I'm starting with Rust as the first language, is it going to be easier or harder? And apparently, the way that the conversation was going is something on the line of, because you don't really have lots of pre-concepts that you might have coming from other languages, it might actually turn out to be easier to learn Rust that way, because you're kind of, you can embrace all these new concepts that generally are the ones that trip you off with Rust. Like, I don't know, the move semantic, that after you call a function and you give the ownership to that function, then you cannot use that variable anymore. I think that's one of the first things that trip people off, because you think, okay, but in any other language I can do that and it's fine. Why Rust doesn't allow me to do this? So I think if you are starting to learn Rust where that's your first language and you embrace the concept as, well, this is the way things work, probably you have less surprises in a sense. So I don't know if like if I would discourage people to try to learn Rust as the first language. I think they might actually have a good experience. Of course, it's not a small language. There is a lot to learn there, so there still needs to be a structure to approach the learning process, like step by step, making sure that they can be productive as early as possible, because of course when you build something and you see it running, that's rewarding and you want to do more. So of course there still needs to be some kind of very well thought path to follow. But I think if you start with Rust as your first language, it's not necessarily going to be a bad experience or a more challenging experience, if you want to call it like that.
Yeah, that's really an awesome perspective. I haven't really thought about that. Now, my perspective is it's difficult to understand, kind of imbibe the concept of borrowing, which is what you were talking about, because it's not so in like other programming languages, and you're just getting to understand that this thing is actually real in Rust because you have experience in other languages. It's going to be difficult for you. But I haven't thought about it in the sense that what if you don't have any prior experience and then you're just faced with borrowing, the concept of borrowing, is it going to be easy or not? That's a really nice debate to look into. But I
Yeah.
don't know. I don't know. Maybe it might be easy because that is the first time you're being exposed to that kind of concept. All right.
Yeah, I think at
So
least it kind of removes that bias that you have coming from other languages saying, well, but if I was doing this with Python, I would be done already. It would be so much easier. I wouldn't have the same constraint. Why do I have to
yeah.
waste my time with this language? I think it definitely removed that argument. So if you are
Mhm.
learning the language with like an open mind saying, well, this is just the way things work, yes, it's still challenging, I think, to really appreciate the depth of a concept like how the borrow semantics work. But then,
Mm.
as if you use that as like this is a piece of fundamental knowledge that I need to have to learn Rust and use Rust, I think you will do that with less biases as when you're coming from other languages. So maybe it becomes a little bit easier to go over that concept, learn it well enough to then become something normal for you to think about when you write code.
Mm. Awesome. So I think what I need to do is to try to get somebody that starts with Rust as their first language and interview them and get to understand their own perspective as to how it was for them when they were learning it. That's awesome. All right. So I have a few questions before we move on to the practical part. And the one that I have here says, what is the best practice? What best practices should backend engineers follow when building serverless applications with Rust? Right. So when you're building serverless
Mhm.
application with Rust, what are some of the best practices that a backend engineer needs to follow?
Yes, that's a good question. I don't know where to start. The first one that comes to mind is do infrastructure as code, just because I think that's probably the first issue that I see with most implementations of serverless applications in general,
Mhm.
is that people don't value enough infrastructure as code, and then in reality is like one of the most important things you should do. And of course this goes beyond Rust. I think that's something you should do with any language.
Mhm.
When you write cloud applications, you will need to most likely to provision that same code in multiple instances. That code will probably need to interact with a lot of different things. So your infrastructure needs to be expressed as code, because otherwise you end up with this messy situation where if you have a development environment and then if you have a production environment
Mm.
created by hand, they will be totally different. And then when you start to upgrade things, even remembering what did you do to upgrade dev before you could upgrade production and all the other environments you might have in between becomes a mess, and that's just a recipe for disaster. So
Mhm.
definitely that's my recommendation. And the good news is that when you use Rust, there are tools that you can use, and hopefully I'll get to show some of that, that will integrate really well with all the usual infrastructure as code tools like Terraform, CDK,
Mm.
CloudFormation, SAM, if you use SAM. So there is no reason why you shouldn't be doing infrastructure as code even when using Rust. You should definitely do that, and it's going to make your life so much easier.
Awesome.
So
So
that's definitely one element.
all right. So yeah, that gives an answer to that question. Now let's move on to the practical part, right? So it's your turn to kind of teach me one or two things about Rust practically. Show
Mhm.
me maybe how to build a project with Rust and serverless, of course, and then how to deploy it. So I'm waiting.
Okay, so I'm going to share my screen in a second. Just going to open a few links first. Okay, let me share the screen. Perfect. So the first thing I want to show is that, of course, well, I want to show how easy it is to deploy our first Lambda function in Rust. I'm not going to do infrastructure as code, which is a bit funny because I just said this is the main thing you should do. But hopefully, I can give you some pointers on how easy it is to do that as a second step, just because of time. Because I think if we want to show us infrastructure as code, this will take probably a little bit longer and we don't have a lot of time. But yeah, where do we start? Of course, the first thing is that you need to have Rust installed. And there are a few different ways to get Rust installed, but the one that I like the most, and I think it's the one that is generally recommended, is this tool called Rust App. So you go to this website, rustapp.ors, and it gives you an installation script. And basically, Rust App is a kind of a meta installer tool. So it's like allows you to install different versions of Rust, keep your Rust version up to date. If you need to install different tool chains because maybe you need to cross compile, it kind of helps you to do all of this stuff. So I would definitely recommend people to install Rust this way because it will make life easy. The other thing we need after we have installed Rust, by the way, this installs Rust and also Cargo, which is the package manager that you can use with Rust. So if you're familiar with JavaScript and Node.js, it will be a little bit like NPM. If you're familiar with Python, it will be a little bit like Pip or Poetry. And I don't know what people use in Java. Is it Maven? I'm not sure. But like, yeah, package manager. So allows you to install libraries coming from public repository where people can publish different kinds of libraries. And when you have Cargo, Cargo actually supports extensions. So you can install packages that will provide additional features to your package manager. And one of these extensions is specifically done for Lambda, and it's called Cargo Lambda. So you can also install Cargo Lambda, and there is a website here. I'll share all the links in the show notes, don't worry. And basically, you can install it in different ways. And then what you can do, the first thing you can do, I'm going to switch here to my terminal. You can do Cargo Lambda init, I think. And we can give it a name, let's say hello. Sorry, it's Cargo Lambda new. And this is, I already have installed, of course, Rust and Cargo Lambda. So the tool is basically giving me a lot of functionality to do a few different things. And the first one we are using is if I want to start a new project in Lambda and Rust, there is a lot of code to set up in the right way. And some of that work is a little bit mundane. It's like, okay, it's always the same thing. I need to create a cargo toml. I need to create a main.rs. I need to create a source folder. I need to install a few libraries. And that kind of initial scaffolding is almost always the same tedious work. So this CLI basically allows you to do all of that in just by answering a few questions. And the first question is, are you doing an HTTP type of function? And I don't know how people are familiar with Lambda in this podcast, but I'm going to give you just a quick overview of that. So Lambda is just a function as a code type of paradigm. So basically, you are writing just a function that is called an handler that takes an input and provides an output. Then you can link that Lambda function to different kinds of events. And depending on the type of events, you can solve different types of problems. So if the event is an HTTP type of event, you are effectively implementing the backend for a web API with your Lambda handler. So for instance, if we wanted to implement an API, we would say here, yes, in the first question, which is something that I want to do. But right now, just to show you, I'm going to say no. And when you say no, then it is already showing you all the other options that you might have. So in AWS, you can interact with a bunch of different events. For instance, if we search for S3, S3 is the storage system, so you can easily upload files into a bucket. It's called the storage place. And then maybe you want to say, okay, every time that there is a new file in this bucket, I want to do something. Maybe, I don't know, you are dropping a video and you want to extract the audio from that video to do some transcription, for example. So you could create a Lambda that does all of that for you, and it'll just listen to that event, like S3 telling the Lambda, there is a new file, do whatever you want with it. So this is just to show you that here you will have an entire list of the most common events, even DynamoDB, which is like a database system, SQS, which is like a queuing system. So you could create Lambdas that handles tasks from a queue. So this is very nice that you can just select the correct thing and it's going to do most of the work for you. And then there is this serded JSON value, which is like if you want to have your own custom event, like, I don't know, one common use case is when you're building a step function. A step function is like a job orchestrator where you can have different steps. And generally, the input of every step is something custom, and the output is also something custom. You can also do custom input and outputs if you want to. Now, I'm going to cancel all of this, do it again, and this time I'm going to say yes, because we want to do an HTTP API, which is probably the most common use case for backend developers, I would say. And in this case, this is really the only question we need to answer about. It's like, yeah, it's an HTTP API? Yes. Okay, I'm going to create a good starting point for you. Now, if we do this, we can see what was created. So we have an hello, which was the name we give to this project. Inside, there is a cargo toml. Then there is a source folder, and there is a main file. So I'm going to open this with VS Code. And we can see the actual code that was created. Okay, so we have a cargo toml. And for people that are not familiar with Rust, a cargo toml is effectively like a package JSON in JavaScript. So it's like where you define all the information about the project, like the name, the version, other properties that might be important for you, but also all the different dependencies that you want to use. And the package manager is going to install them for you. And here, the different things that we got already is this Tokyo, which is the async runtime that, well, one of the many async runtime, but it's probably the most famous. So inside the Lambda, we'll need to be able to write this handler. And because we want to use async code, this is something that allows us to use async. I'm oversimplifying, but that's the reason why Tokyo is there. And then Lambda HTTP is another package that basically makes it a little bit easier to do request and response in HTTP, translating all the inner working of Lambda. In Lambda, the events are always JSON coming in and JSON going out. So when you want to do HTTP, there is a kind of a translation layer where a JSON coming in needs to contain all the properties of a typical HTTP request, like headers, the body, and I don't know if you have query string parameters, all this kind of stuff. This Lambda HTTP gives us a typed way to effectively use all these different pieces of information and create a response that is a valid HTTP response for Lambda. So if we look at the code, it did create a main.rs, which is pretty nice because this is already implemented like an hello world type of problem. And we'll go through the code in a second. I just want to show that there are two main parts. There is this thing called function handler, and there is this thing called main. Now, in Lambda, there is a very specific life cycle. So, as I said before, basically, you don't have any code running if there is no event in the cloud, right? When an event happens, the cloud provider needs to bring up an instance and then execute your code. So you might think of these two separate pieces of code here, these two different functions, as this is the init code. So this code will only be executed once when the instance is created for the first time. So if you have an event coming in, an instance is created, this code will be executed. And what this code does is effectively doing a loop. Now, here is not obviously a loop, but trust me that this code inside is doing like an endless loop. And this endless loop is always asking AWS, well, I am an instance that just came up. I don't know anything about the cloud. What is the environment that I'm running on? So it's basically asking AWS, is there an event that I need to handle? So this is happening in a loop. And every time there is a new event, it's going to call this function handler here. So effectively, you can imagine this is just setup code that is starting this loop of getting new events. But then this is really where we are going to be writing our business logic. So a new event comes in, we need to do something with it, produce a response, and then we stop, and then let this loop continue and eventually trigger another event. Does that make sense?
Yes.
Perfect. So what is the logic here? And of course, this was implemented for us, but we can see that we have an event, which is a request. And this request comes from that HTTP library that we saw before. So here we can get things that you could generally get from a web framework if you want. Like if you have used any other web framework, you would have some kind of request object. And from a request object, you can do things. Okay, I want to get the query string parameters and see if there is a parameter called name. And then if there is, I'm going to use it. Otherwise, this syntax means otherwise I'm going to use as a default world. So if nobody said name, I'm going to assume that the default for name is world. And then at the end, I'm going to create a message. So this is just creating a string saying hello, whatever name. So this is going to be world by default. But if you provided a name as a query string, that's going to be the name you provided. This is an AWS Lambda HTTP request. And then we are creating a response. So this is like an HTTP response. So where we say the status of this response is 200. We want to provide an header that is just saying text HTML. And actually here, to make this nicer, we can do a little bit of formatting. I don't know. Let's do strong. So this will be in bold. Just to show that this is actually creating an HTML response. And then at the end, we say, okay, this is the body that we want to include in our response. And then finally, if there is any error, we're going to return that error. And we complete here the request. So does all of this make sense?
Yes.
Okay, so the next question might be, how do we test if this even works, right? So if we go back here, what we can do is we can do cargo lambda watch. And what am I doing wrong? Let's see. Oh, do I have this port being used? Probably. Okay, let me make sure I don't have other terminals running. Or can I specify a port? Yes, there is invoke port, so probably what I want. Let's use 9001. Okay, that's working. So I have something running on that port somehow. And I don't want to debug it now. So what's happening now is that this is basically starting a local simulation of the Lambda function, the Lambda environment where it's running our Lambda function. And because it's in watch mode, if we do any change in the code, this is going to automatically recompile for us. Now it looks like it's not doing anything. In reality, it's just waiting for us to do an invocation. So this process is currently blocking my terminal. So one thing I can do is split the terminal horizontally, and here we can say cargo lambda invoke. And this is one thing we can do, but I think I need to give again the what was it? Invoke port, I think.
Yeah, you can just use P, I think.
And it was 9001, I think. Oh, yeah, sorry. This needs to be before that example. I will explain all of that in a second. Okay, so what's happening here is that this is basically invoking our Lambda function with an example request that I will give you a link, but basically there is an entire repository where you can specify the JSON file. Well, you can find all the default JSON files for like HTTP request, SQS, S3. So of course the problem is that we need to provide an input that is conformant to the specification of the type of Lambda that we are writing. So this example just contains like an hello world where the name is me. It's not world, but it's me. So basically we can see here, if I do this in a nicer way, if we format the response, that the response is also a JSON. And this is the JSON that when you use, for instance, API Gateway, API gateway is expecting from Lambda, and then it's going to convert it back to an actual HTTP response to the user. So there is a status code, there are headers that we are specifying here, because you can also have multi-value headers. And text HTML is what we specified in our code. And then there is a body, which is this HTML body that we created. Now, if all of that makes sense, the next step will be, how do we deploy this Lambda to AWS? Because now we are happy, this is just running in our machine, but we want to show it to, I don't know, our friend. So we want it to deploy remotely and get a URL that they can call. Okay. So I'm going to stop all of this and close this one. At this point, the next step is cargo lambda deploy. And here there is a little bit of a topic that we can get into, but I'm going to simplify. So generally, there are different ways to do HTTP with Lambda. The most common one is to use API Gateway, which is an entire service that allows you to define, I don't know, routes and methods, and then you can connect those routes and methods to different things, one of which is Lambda. But there are other ways that are a little bit simpler, and we're going to take a shortcut. And one of these ways is what is called function URL, which is basically just not creating any API gateway, but it's just taking our Lambda function and creating a URL for that function. The reason why it's a little bit of a shortcut is because you don't get all the features that you have with API gateway. There are also some security concerns. You cannot really control the URL as nicely as you can with API gateway. But for our test, this is probably fine. Okay, so what am I doing wrong here? Oh, yes, I didn't build it. I need to build first. Sorry about that. Yes. Cargo Lambda build. And the cool thing here is that we can also specify an architecture. Mm-hmm. And in general, if you use ARM64, it's going to be a little bit cheaper and potentially faster. In some cases, ARM64 is a little bit faster than the default one, which is x86. So the nice thing is that Cargo Lambda will make sure to build your code correctly for the architecture you're specifying here, regardless of your current system. So for instance, I don't know, right now I'm in a Mac with a silicon chip, so it can do ARM compilation easily. But if I was using a different kind of machine, well, the thing is that also needs to compile for Linux, because the AWS target is going to be a Linux. So it's basically going to make sure that the destination operative system and the destination architecture are correct for what you need to do in Lambda, regardless of your actual machine. So, awesome. Which is nice, because if you need to solve that problem yourself, it can be a little bit of a headache to, I don't know, cross-compile or figure out all the configuration options you need to use. Like, this is abstracting a lot of complexity away for you. And this is one of the common problems with compiled languages that, yeah, with interpreted languages, it's like you just have script files, you put them in a zip file, and you don't need to worry about compiling for the right target. Yeah. Here, there are a few extra steps, but thankfully, this tool makes them practically non-existent. You just need to run the build, but it's going to build it correctly for you. Okay, now that we have the build ready, we can deploy. Hopefully, this time it's not going to complain. Okay, what it's doing is basically, it's basically creating a zip file and sending it to AWS. I am already logged in into my account. Of course, you need to be logged in into an account and have the AWS CLI. But if you have done all of that, we got our own URL. So this is the ugly function URL, but this should point to our function. So to prove that this works, what we can do is just this. And we see hello world here. We can also do another thing, because we said, well, we support a query string called name. And here we can say Solomon, for example. And here is saying, hello, Solomon, this is an AWS Lambda request. So this is kind of showing that our code works. And if we want to see it a little bit nicer, we can see that in the browser. And yeah, it's showing that basically, yeah, the thing is working. Maybe if we want to do one change very quickly, we can say, I don't know, style, color, red, right? Why doesn't like it?
Single quotes.
Oh yeah, all right. So let's do the escape. I think it's the easiest. And if we do again cargo build, cargo lambda build. Let's see how fast it does this change. By the way, this is another problem with Rust if you really want to be picky, that sometimes compilation times are not as instantaneous as you might expect. For instance, here it took 10 seconds. Like you might expect, by the way, this is doing a production build. When you use release, it's doing a lot more optimizations. In development, it will be a little bit faster, but it's still 10 seconds. So some people might complain that it is a bit slow. Okay, now we do another deployment. This time the deployment was much faster because the first time it's creating the Lambda, it needs to create a few more things, like it needs to create policies, logging groups, and a bunch of things around the Lambda. Here it knows, okay, this Lambda already exists. I just need to swap the code with a new version of the code. So it took, I think the first time it took 40 seconds. There we see. Here it just took 12 seconds. Now, if we go back to the browser, hopefully we will see this in red. So you can see that this is like a nice feedback loop to improve our application. Now, I'm going to mention just one thing, just we don't have time to go through it right now, but hopefully it's going to be interesting for people, and I can give you a presentation that I did with a workshop where there are more examples. But you can probably see immediately that the problem right now is that, well, this is a simple function, but imagine that now we want to interact with a database. Like if we want to do anything useful, you probably want to interact with, I don't know, DynamoDB. And suddenly you have the problem, okay, how do I create the DynamoDB table? And you can go in the AWS console and create it manually. And then you have the problem, okay, now this table has a name that my function needs to know. And also I need to create a policy for that function that allows it to read or write from that table. So there is a lot of resources that suddenly you need to start to create and also connect with each other. And you can do all these things manually, but if you do it with infrastructure as code, then everything is like in one place, and you can easily say, deploy this project. This is the only thing you need to worry about, not which pieces of this project have changed and how do I replicate those changes in another environment. You just said, this is the state of my project right now, deploy it. If you have an instance of that project already deployed, the infrastructure as code is going to figure out the changes and do them correctly for you. If you are deploying from scratch, it's going to deploy everything that needs to be deployed. And you always end up with a consistent state at the end. So the link I want to show you is basically, if we go back to Cargo Lambda, there is some documentation here. Let's see if I can find it. That should show us how to use it with infrastructure as code. There we go. Okay, for instance, here there is an example with CDK where I don't know if people are familiar with CDK, but it's one way to do infrastructure as code where this code is effectively describing all your infrastructure. Here there is a policy, for example, there is an IAM user, there are access keys, other stuff here with Terraform as well. Now, this is just to do automated deployment, so it's not exactly what I wanted to show, but somewhere I think there is an example here. I remember seeing it. Okay, I'll show it from my own slides then. So I'll share this link with you afterwards, but basically here I have an entire workshop presentation where one of the section is exactly showing how to do infrastructure as code. So it shows everything we covered today, but then from here, this is basically the code that you need to write to do like a Lambda with some, and then you can use some to do the deployment. And here eventually is going to add also a DynamoDB table and show you the difference and how to deploy. So that's, I would recommend to follow this if you want to see an example on how you can use infrastructure as code. That's all I have. I don't know if you have any more questions at this point.
So clearly, it's awesome because you can quickly just deploy an application very fast, and it's really beautiful. But I still feel like for people to completely understand everything that is going on, they need to kind of understand Rust. They need to learn Rust first. And I'm taking it from the example when you were asking me if I understand, the code. Yeah, I do. I understand the code, but other people might not because they don't really understand maybe the Rust programming language itself. And then another thing is they also need to understand Lambda text. Oh, sorry, I said Lambda text. Lambdas, right? They need to get to understand that and, combine this knowledge together to have a functional applications built with Lambdas and Rust, which is great. But you've done a great job, and I'm going to share the slides and the links to, the resources that you have shared. Yeah. So thank you very much for your knowledge sharing, and that is really, really awesome.
Yeah, thank you very much for having me. I think it was a great pleasure and hopefully was useful. And I think if people have questions, feel also free to reach out to me. You will probably share also my personal links, but I'm generally happy to try to answer people's questions. So yeah, don't be intimidated if you want to ask.
No. So so before we go, I I want to share a couple of announcements. First, I want to start by letting you know that you can actually learn Lambda functions in Rust. Using a book from Luciano, right?
Mhm.
So the name is Crafting Lambda Functions in Rust. All right. So I'm going to share the link, but you can, share your screen again and talk to us about the book. Right. I think that would be really, really helpful.
Okay, so I'll do that super quick. Thank you, by the way, for giving me the opportunity to share the book as well. Okay, hopefully you can see this. So this is the website of the book. It's called rust-lambda.com. This is the name of the book, as you suggested. So the idea is that, by the way, I'm co-authoring this book together with James Eastham. James, if you're following, hello. And the idea is that myself and James have been playing a little bit with this idea of doing Lambda functions using Rust, and we definitely realized the benefits. But we also realized that there isn't a lot of material out there. So we thought, okay, what if we try to create a book that gives people a little bit of an introduction and also not just the theory, but also like a practical project that they can build together with us as they go through the book that showcases all the common concerns. And I'm just going to scroll through here and basically just to show what is the structure of the chapters. So there is a kind of an introduction on the why. Then we start to build an Hello World API, pretty much similar to what we did today. Then we start to use infrastructure as code, which is definitely what I would recommend to be the next step. And then we start to actually build a real application here where we're going to be building like a URL shortener. So effectively, you can give the system a URL. This URL is going to be stored in DynamoDB, and then it's going to give you an ID that you can use to build a short URL that allows people to visit website through short URLs. Also tracks the number of clicks, tracks some metadata about the links that you are creating. So it's a simple enough application, but then we can start to look into how do you organize it, like splitting the functionality in different lambdas, and then how all the different lambdas work together. How do you make the code testable? And by the way, we have these 2 chapters almost ready. I hope that by the time this podcast is out, these 2 chapters will be available. And then other things like, well, it's just HTTP. No, there are lots of different types of events that you can handle. Like we mentioned using queues, we mentioned reading files from S3 and so on. Then how do you write different Lambda handlers? For instance, how do you manage, I don't know, configuration? If you need to read secrets, if you need to provide your Lambda handler lots of information before you can do its job, what are the different ways to organize all of that data retrieval? And this brings us to the next section. So configuration management and handling secret, observability, middlewares, and so on. So there are lots of topics that you can see they go from like zero to very advanced. So maybe most people don't care too much about, I don't know, writing Lambda extensions, which is a very advanced topic. But I think here what we want to do is try to give an overview of everything that it is possible with Rust and Lambda together by building something somewhat practical. Like at the end, you should have a project that you can run in production and it can be actually useful to you. And the final thing that I want to mention, maybe it's not obvious from here, like this book is a work in progress, but you can already buy it. So it's highly discounted right now. So what you are buying is an ebook that effectively gets updated as we have new chapters, and you will always get the new versions for free. So you buy it once, you will get every update forever.
Awesome.
So that's everything I have.
Yeah, that's beautiful. And again, I can actually vouch for you for producing quality books. I actually have one of your books right here. So you see,
Oh, nice.
I have one of your books right here, and it's been really, really instrumental for understanding design patterns in Node.js. Right. So I can vouch for you in terms of the quality of the books that you are going to produce. And that one is going to be great.
Thank
I'm
you for
definitely
that.
going to check that out.
Yeah,
All
that's
right.
the
So
other book you're talking about. Yeah.
exactly. Okay. So if you're interested, go and get it. All right. So in as much as we have lambdas in Rust, if you're not familiar with Rust, you need to learn Rust first before you move to lambdas. And Mastering Backend has a very awesome course that takes you through Rust. Okay, so like I said before, it follows the roadmaps, the roadmap.sh Rust roadmap, right? So it follows that from A to Z, and we try to teach everything for you to understand Rust. So I'm going to show you the models that we have. Let me just share my screen here. Sorry. All right, so I was actually looking at your book. It's better here.
In dark
You
mode,
see
yes.
Yeah. So the design is much better here. All right. So now here is the Rust book, the Rust course rather. So we are looking at different concepts. So first we start with the essentials, trying to get to understand Rust, and then we go into advanced concepts, things like lifetimes, generics, and all of that. And then we move to testing. And since we're talking about backend development with Rust, we quickly move into web development with Rust, where we talk to you about different frameworks that are now very popular in Rust, like Active, Axiom, and Rocket. And then we really go deeper into one of the framework, which is Active Web. And then we start building RESTful API. So here we introduce the project-based learning system, where we build real-life projects. And after that, we talk about GraphQL, databases, we talk about containerization, where we talk about Docker and all of these important technologies that you can use with Rust. And then we look at deploying. Okay. So most importantly, we talk about building your own load balancer and 10 more other projects that you can use to practice. So it's more like a detailed course on Rust, and you can get started right here. So it is still, a work in progress, like I said. So we have the first model out, and we are looking at more models to come up in the future. So I'm going to link to all of these resources that you can get started with. And again, we want to say thank you very much to Lucian for joining us today and talking about Rust. And I'm definitely going to get this book again to add to my collection because I believe in the products that you put out there. Thank you very much for joining.
Thank you for having me, and thank you everyone for following on.
All right, so we've come to the end of this podcast. If you have any question, please make sure to drop them on anywhere you are watching this from, and I will definitely answer it, or I'll get it to Luciano to answer it, and I'll get back to you. So I'm also going to drop his contact link, like Twitter, LinkedIn, so that you can connect with him. He's very, very knowledgeable around full stack development. So, all right, so see you in the next episode.